session. Today my topic is multi-layer perception activation functions, rule segment softmax. Introduction to activation functions. Activation functions are crucial components of neural network, influencing how models learn and make predictions. They introduce non-linearity into the model, allowing it to learn complex relationships within the data. In the perception, we will explore three popular activation functions used in multi-layer perception: rule, standard, and softmax. Here are some examples in the above diagram. What is multi-layer perception? A spectrum. A multi-layer perceptron uh, called as MLP is a type of non-feed-forward artificial network. It consists of multi-layer of neurons, including a input layer, one or more hidden layers, and an input layer and an output layer. MLPs are capable of learning complex patterns due to their layered architecture and activation functions. Here the yellow dots are input layers and the green dots are hidden layers, which acts as a working structure. The output is repeatable. Overview of activation functions. Activation functions determine the output of neurons in neural network. They can significantly impact the performance of the model by affecting convenience and learning. Different activation functions serve different purposes and suitable for various types of problems. Here the activation functions equations examples is a 1D graph. Linear is alpha of z equal to z. Example abelian line linear recreation. Here the 1D graph of linear structure. Logistic logistic alpha alpha of z is equal to 1 by 1 plus e minus z. Logistic regression multi-layer NN. Here the 1D graph of the logistic. Hydraulic NN. Alpha alpha of z is equal to e power z minus e power minus z by e power square plus e power minus z. Multi-layer neutral networks. Here the 1D graph of the hydraulic NN. 55 rule rectified linear unit. Alpha of z is equal to max 0 comma z multi-layer neutral network. Introduction to rule. Reflected linear unit. Rule is defined as f of x is equal to max 0 comma x, meaning it outputs the input directly if it is positive and 0 otherwise. It is computationally effective and helps magnetic mechanics gradient problem of seen with other activation functions. U is widely used in hidden layers of deep neutral network due to its simplicity and effectiveness. Here are some graphs. Advantages of rules. Neural rules always for faster training of these networks as it enables more models to learn more quickly. It helps to create fair representation, reduce the number of neurons activated at any given time. The function does not search for positive values, help to maintain linear flow during back back backpropagation. Characteristics of synapse function. Transformation of rapid to reduced growth, initial rapid growth, recorded growth, D is modified graphic function. alpha, beta, gamma. Disadvantage of rule. Rule can suffer from the timing rule problem where neutrons can be inactive and stop learning entirely. Negative input values are mapped to zero, which may lead to less of information. Variants like lucky rules and parametric rules have been proposed to address some of these issues. Active functions, advantage and disadvantage. Synapse. Synapse functions has a well-defined non-zero state direct to everyone, unlike step functions, which allows the optimizer to make some progress at a very deep duration timing. Training. It suffers from vanishing gradient problems, slow due to its exponential operations and also not zero centric. Restrictive or steeper compared to China, output is zero-centric. Disadvantage suffer from vanishing gradient problems. Rules. Advantage. To fix the vanishing gradient problem, root is less compatible, explosive compared to fan on cyanide due to its similar mathematical operation. Suffers from diving rule problems due to negative impact. Waits advanced steps on non-information is passed to next layer. Leaky rule. Leaky rule is fixed diving rule problem by introducing small negative slope. It is processed linearly. It cannot be used for complex classification. Suffer from vanishing gradient problems. Look. Unlike ReLU, ELU can provide negative outputs, fix both diving rules and vanishing gradient problems. Disadvantage. For x greater than 0, it can below of the iterative with output range 0 to alpha or infinity. Compatibility in test softmax. Help from multi-classes predictions usually use the last layer. Introduction to cyanide activation functions. The cyanide function maps any input to a value between 0 to and 1, making it suitable for binary classification tasks. It is defined as f of x is equal to 1 by 1 plus e power minus x, which produce an S-shaped curve. Cyanide was widely used in early neural networks, but it falls out forever for deep learning due to its limitations. Advantages and disadvantages of cyanide. The cyanide function produces smooth gradient which can help during the optimizing process. However, it suffers from the vanishing gradient problem, especially when it's far from zero. If output is not zero-centered, which can lead to inefficiency in the learning process. Introduction to softmax activation function. Softmax is typically used in the output layer of a neural network from multi-classes classification problems. It converts raw stores logics into probabilities, providing a normalized output the sum of to 1. The function is defined as a f of x I is equal to e power x of I by sigma e power x of I minus, where x of I is presents the logic for each class. Why is the softmax function used for the output layer? In a neural network, the output variable is modeled as a probability distribution where the output may node different values that output variable can take or not mutually exclusive to each other. The softmax function is a generalization of the logistic function. It is a sequence that creates a generalization of logistic function. It first dimensions output variables into a k different dimensional probability variable taking that value. Here we are using softmax formula. S of y of I is equal to hp y of I by sigma n j is equal to 1 xp y of I, where y is an input vector to softmax function H gives consistence of n electrons for n classification possible outcomes. Y of I, the ith element of the input vector, it can be take any value between minus info and plus information. Exp of y, standard exponential function applied of y, then result is also small, close to zero, but never zero. If y greater than less than zero and a large value, if y is large. Example 55 is equal to 7 plus 23 is very large number. Minus 55 is a very small number. N sigma n j is equal to 1 experiment y of n. A normalization times in ensuring that values of output vector sum of 1 for I class and each of them is a range of 0 to 1, which makes up a valid probability distribution n number of classes. Conclusion from the composition of activation function. Each activation function serves a different purpose and it is best suitable for specific types of task. The rule is followed in a hidden layers leaf network, where cyanide is commonly used for binary outputs. Objects is essential for multi-classes classification, ensures that outputs are interpretable and probability. And thank you.